In this video, I will explain how to find the average rate of change of a function over an interval. So the formula that we use to find the average rate of change of a function over an interval is f of x2 minus f of x1 divided by x2 minus x1. So I have a couple examples for us to work through here. Let's take a look at the first one. We have f of x equals x squared minus 5x plus 7. We want to find the average rate of change of this function over the interval 5, 10. So for this particular example, the first x value is 5, and the second x value is 10. So all we need to do to solve this is plug each of these values into this function and solve for the function. And then we'll plug whatever we get back into this rate of change formula. So let's plug the first value, and let's plug in 5 into this function. So we'll say f of x sub 1 is equal to, so we're going to plug in 5 for each x value. So 5 squared minus 5 times x, 5 times 5, plus 7. So simplifying, we get 5 squared, that's 25, minus 5 times 5, that's 25, plus 7. So we get 25 minus 25, that's 0, plus 7. So the function f of x sub 1 is just equal to 7. So now we'll do the same thing with this second x value. We'll plug in this 10 into this function and see what we get. So f of x2 is x squared, so 10 squared minus 5 times 10 plus 7. So we get 10 squared is 100 minus 5 times 10, that's 50, plus 7. So we get 100 minus 50 is 50, plus 7 is 57. So now that we have solved for both of these, we can just plug these numbers into this average rate of change formula. So we get f of x2, so we figured out that is 57, minus f of x1, we figured out that was 7, divided by x2 minus x1, so x2 is 10 and x1 is 5, so we'll say 10 minus 5. So 57 minus 7, that is 50. And then on the denominator, we have 10 minus 5, that's 5. 50 divided by 5 is 10. And that is our final answer. So the average rate of change over the interval 5 to 10 of this function is 10. So let's take a look at our second example. We have f of x equals x cubed plus 2. We want to find the average rate of change of this function over the x interval -1 to 2. So again, in this example, this is our first x, and this value of 2 is our second x. So we'll do the same process. We'll plug in each of these values into this formula and see what we get. So f of x1 is equal to x cubed, so -1 cubed plus 2. So -1 cubed, so -1 times -1 times -1, that's just -1, plus 2. -1 plus 2 is 1, a positive 1. Okay, now we'll plug in our second x value, and we'll get, so x cubed, 2 cubed, plus 2. So 2 cubed is 8 plus 2. 8 plus 2 is 10. And now we will just plug these values into our average rate of change formula. So we get f of x2 we saw was 10 minus f of x1 is 1 divided by x2 minus x1. So x2 was 2 and x1 was -1. So minus a -1. So in the numerator we get 10 minus 1 is 9. In the denominator we get 2 minus a -1. That's the same as 2 plus 1, which is 3. And 9 divided by 3 is 3. So that is our final answer for this one. That is the average rate of change of this function over the x interval -1 to 2. Thanks for watching.